This Christian holy relic is referred to as the Shroud of Turin.
The Shroud of Turin is this amazing relic. At bottom, it's a piece of cloth. It shows a very faint sort of image of a crucified man.
Arguably the most intriguing and controversial religious relic in the world, the Shroud of Turin.
Some say it's a medieval forgery. Others believe it's the burial cloth of Christ. But now AI has revealed something no one expected. Welcome back to the channel, Mystery Hunters. Today, we're diving into the mind-blowing intersection of the latest artificial intelligence and the world's most debated religious artifact. The discoveries coming out of AI laboratories around the globe are so extraordinary that even the most skeptical scientists are having to reconsider everything they believed about the Shroud of Turin. Trust me.
On findings being published in a new book out today on the Shroud of Turin.
What you're about to discover will leave you questioning the very nature of historical evidence itself. The Shroud phenomenon. Before we dive into the AI revelations, let's set the stage. The Shroud of Turin is a 14.5 foot by 3.7 foot linen cloth that bears the faint but unmistakable image of a crucified man. For centuries, believers have claimed this is the actual burial shroud of Jesus Christ.
New discovery regarding the Shroud of Turin. Reports say there is new evidence the shroud is 2,000 years old.
While skeptics argue it's a medieval forgery created around 1260 to 1390 AD. But here's what makes this artifact absolutely fascinating. Regardless of whether you believe in its authenticity, the shroud possesses characteristics that shouldn't exist according to our understanding of medieval technology. The image isn't painted, dyed, or scorched onto the fabric. Instead, it appears to be created by some kind of chemical alteration that affects only the topmost fibers of the linen threads. The image on the cloth is actually a photographic negative, meaning it reveals a positive image when photographed, a property that wasn't discovered until 1898, when photographer Secondo Pia made this remarkable observation. This negative quality creates incredibly realistic three-dimensional information that has puzzled scientists for over a century. What's even more intriguing is that the image contains anatomically correct details that would require extensive medical knowledge to fake, details about human anatomy, blood flow patterns, and wound characteristics that weren't widely understood in medieval times. The AI revolution. Why is artificial intelligence revolutionizing how we study historical artifacts? Because modern AI systems can analyze images with a level of detail and precision that human researchers simply cannot match. We're talking about technology that can detect microscopic patterns, identify chemical signatures, and spot inconsistencies that would take human scientists decades to discover. AI image analyzers can translate changes in light and dark pixels into three-dimensional relief maps, essentially creating detailed topographical information from flat images. This technology was originally developed for analyzing lunar surface features, but researchers quickly realized its potential for studying historical artifacts like the Shroud of Turin. The AI systems being used for shroud analysis are looking at the obvious features. They're examining pixel intensity variations, detecting microscopic color changes, analyzing fabric weave patterns, and identifying chemical compositions that are invisible to the naked eye. This level of analysis is revealing details about the shroud that researchers never knew existed. What makes AI particularly valuable for shroud research is its objectivity. Unlike human researchers who might be influenced by personal beliefs or preconceptions, AI systems analyze data purely based on mathematical relationships and pattern recognition. They don't care about religious implications or historical controversies. They just process information and reveal what the data actually shows. Breakthrough discoveries in image formation. Here's where things get absolutely mind-blowing. AI analysis is revealing that the image formation process on the Shroud of Turin involves characteristics that challenge our understanding of both medieval capabilities and natural processes. Recent research suggests the image was likely formed by a burst of ultraviolet radiation, creating what scientists describe as a photographic quality that shouldn't be possible with medieval technology. The AI systems analyzing the image formation patterns are finding evidence of energy processes that operate at the molecular level. The artificial intelligence has identified that the image penetrates only about 200 nanometers into each linen fiber. That's about 1/500th the thickness of a human hair. This level of precision in image formation suggests a process that could control energy application at the microscopic level, creating uniform coloration across the entire cloth while affecting only the surface molecules of each thread. But here's what's really keeping scientists awake at night. The AI analysis suggests that this energy burst would have had to occur uniformly across the entire 14.5-foot length of the cloth simultaneously. We're talking about a process that could coordinate energy release across multiple square feet with nanometer-level precision. No known medieval technology could achieve anything remotely close to this level of control. The AI systems have also detected that the image formation process left no signs of thermal damage to the underlying fabric structure, suggesting that whatever created the image operated at temperatures that wouldn't damage linen fibers while still causing the chemical changes necessary to create the visual image. Revolutionary dating analysis. One of the most controversial aspects of Shroud research has been carbon dating studies from 1988 that suggested a medieval origin. However, AI analysis is now revealing problems with those original dating methods that nobody anticipated. Recent X-ray dating tests by the Institute of Crystallography in Italy indicate the shroud is actually a 2,000-year-old relic, contradicting the earlier carbon dating results. But what's particularly interesting is how AI is helping researchers understand why different dating methods are producing conflicting results.
Through the generations, many have tried to decode the Turin shroud's secrets. The image it carries is clear, but there's no trace of pigment.
The artificial intelligence systems analyzing the shroud's fabric structure have identified areas of contamination, repair patches, and environmental damage that weren't properly accounted for in earlier studies. The AI can detect microscopic differences in linen fiber structure that indicate different ages for different parts of the cloth. AI analysis has identified Middle Eastern pollen grains embedded in the linen that support the theory of the shroud's regional origin, providing additional evidence that the cloth originated in the geographical area where Jesus lived and died. These pollen grains represent plant species that grow specifically in the Jerusalem region and wouldn't be found in medieval European locations where critics claim the shroud was created. The AI systems are also analyzing the weave patterns in the linen fabric itself, comparing them to known textile production methods from different historical periods. The results suggest manufacturing techniques consistent with first-century Middle Eastern textile production, rather than medieval European methods. Forensic blood analysis. Breakthroughs. The analysis of bloodstains on the shroud. Yes, this is where artificial intelligence is revealing details that are absolutely staggering. New studies analyzing the blood on the shroud argue that the stains are consistent with the torture and crucifixion of Jesus Christ, as described in the Gospels. But the AI analysis goes far deeper than simple pattern recognition. It's revealing forensic details that would require extensive medical and anatomical knowledge to fake. Scientific analysis indicates the bloodstains are real blood, specifically type AB blood, containing biological markers of trauma, injury, and clotting. The AI systems can detect the chemical signatures of genuine human blood while identifying specific characteristics that indicate the person suffered severe physical trauma. AI analysis shows bloodstains on the wrist rather than the palm, which is forensically more plausible for crucifixion. This detail is particularly significant because medieval artwork typically shows crucifixion nails through the palms, but forensic science has proven that nails through the palms wouldn't support body weight. The shroud shows anatomically correct placement that wasn't understood until modern forensic research. The artificial intelligence has also identified blood flow patterns that are consistent with specific body positions during crucifixion and burial. AI analysis indicates the blood patterns are only consistent with arms positioned at approximately 45 degrees, matching historical accounts of Roman crucifixion techniques. The AI facial reconstruction phenomenon. One of the most fascinating applications of AI to shroud research involves attempts to reconstruct the actual face of the person whose image appears on the cloth. Recent AI-generated images supposedly provide an accurate representation of the man on the Shroud of Turin, and the results are absolutely remarkable. The AI facial reconstruction process involves analyzing the three-dimensional information embedded in the shroud's image, then using sophisticated algorithms to reverse engineer what the actual face would have looked like. The artificial intelligence systems can detect subtle variations in image intensity that correspond to facial features, bone structure, and tissue depth. Comparison between AI-generated faces and the shroud image shows significant similarities, though with some differences in facial proportions. The AI reconstructions tend to show longer faces with higher cheekbones and more defined features than traditional artistic representations of Jesus. What's particularly interesting is that different AI systems, working independently with the same shroud data, are producing remarkably similar facial reconstructions. This suggests that the three-dimensional information in the shroud image is mathematically consistent and contains genuine anatomical data rather than artistic interpretation. The AI facial analysis has also revealed details about the person's apparent age, ethnicity, and physical condition at the time of death. The reconstructions suggest a Middle Eastern male in his 30s who had experienced significant facial trauma, consistent with gospel accounts of Jesus' crucifixion. Controversial conflicting evidence. However, not all AI analysis supports the shroud's authenticity, and it's important to examine the conflicting evidence that's emerging from different research approaches. Some studies using modern forensic techniques suggest the bloodstains are completely unrealistic, with patterns inconsistent with a body lying flat. These AI analyses argue that the blood patterns show inconsistencies that would be impossible if the cloth had actually wrapped a crucified body. Recent 3D analysis suggests the shroud image might have come from a sculpture rather than a human body, challenging fundamental assumptions about how the image was formed. This research uses AI pattern recognition to argue that the three-dimensional characteristics of the image are more consistent with contact with a rigid object than a flexible human body. The conflicting AI analyses highlight a crucial point about artificial intelligence research. The technology is only as good as the data and assumptions programmed into it. Different research teams, using different AI approaches and focusing on different aspects of the shroud, are reaching dramatically different conclusions. Some researchers have even conducted experiments with volunteers to test blood pattern formation during crucifixion, using AI analysis to compare experimental results with the shroud patterns. These studies suggest that some blood patterns on the shroud are inconsistent with known physics and anatomy. The authentication challenge. One of the most significant challenges facing AI analysis of the shroud involves the fundamental question of authentication. How can artificial intelligence distinguish between genuine ancient artifacts and sophisticated medieval forgeries? Current shroud research presents extraordinary challenges in forensic archaeology and image analysis, with any proposed formation mechanism needing to satisfy over 35 documented physical, chemical, and forensic requirements. This complexity is both supporting and challenging different theories about the shroud's origin. The AI systems analyzing the shroud are essentially trying to solve a multi-dimensional puzzle where every piece of evidence must fit together consistently. If the shroud is authentic, then all the physical, chemical, biological, and historical evidence should align. If it's a forgery, then inconsistencies should emerge when all the data is analyzed together. What's making this particularly challenging is that the shroud displays characteristics that seem impossible for both medieval forgery and natural formation processes. The AI analysis is revealing a level of sophistication that medieval technology couldn't achieve, but also characteristics that don't match any known natural process. The artificial intelligence systems are also analyzing the historical provenance of the shroud, examining documentary evidence, artistic representations, and historical records to build a comprehensive timeline. This historical AI analysis is revealing gaps and inconsistencies in the shroud's documented history that complicate authentication efforts. Chemical composition mysteries. AI analysis is also revolutionizing our understanding of the shroud's chemical composition, revealing molecular-level details that weren't previously detectable. The artificial intelligence systems can identify specific chemical compounds present in different areas of the cloth, mapping the distribution of various substances across the entire shroud surface. This chemical mapping is revealing patterns that provide clues about the image formation process and the cloth's historical environment. One of the most intriguing discoveries involves the detection of chemical signatures that suggest specific geographical origins. The AI can identify trace elements and chemical compounds that are characteristic of particular regions, potentially confirming or contradicting theories about where the shroud originated. The AI analysis has also detected evidence of various conservation treatments applied to the shroud over centuries, helping researchers understand how these treatments might have affected dating studies and other scientific analyses. This information is crucial for interpreting conflicting research results from different time periods. Perhaps most significantly, the AI chemical analysis is identifying molecular-level changes in the linen fibers that created the image. These changes appear to involve oxidation and dehydration processes that affected only the surface molecules of each fiber, creating the image without penetrating deeper into the fabric structure. Microscopic fiber analysis. The level of detail that AI systems can detect in the shroud's individual fibers is absolutely astounding. We're talking about analysis at the molecular level that's revealing information invisible to traditional microscopic examination. The artificial intelligence can analyze thousands of individual linen fibers, mapping variations in color, chemical composition, and structural integrity across the entire cloth. This fiber-by-fiber analysis is creating the most detailed map of the shroud ever produced. One of the most significant discoveries involves the identification of fibers that show different aging characteristics, suggesting that the cloth has been exposed to various environmental conditions over its history. The AI can detect microscopic differences that indicate repair work, contamination, and environmental damage that occurred at different time periods. The fiber analysis is also revealing information about the original manufacturing process of the linen cloth itself. The AI can detect variations in thread thickness, weave tension, and processing methods that provide clues about the textile production techniques used to create the original fabric. Most remarkably, the AI analysis is identifying specific fibers that contain the image formation chemicals, while adjacent fibers show no similar changes. This suggests an incredibly precise process that could affect individual fibers without influencing neighboring threads. Pattern recognition across cultures. One fascinating application of AI to shroud research involves comparing the image characteristics to similar artifacts and artistic representations from various cultures and time periods. The artificial intelligence systems can analyze thousands of historical images, artistic works, and archaeological artifacts to identify patterns and similarities that might provide clues about the shroud's origins and cultural context. This comparative analysis is revealing connections that human researchers might never discover. The AI has identified artistic techniques, symbolic representations, and iconographic elements in the shroud that appear in various cultural contexts throughout history. Some of these connections suggest influences from multiple cultural traditions, while others point to specific regional artistic practices. Perhaps most intriguingly, the AI analysis is finding elements in the shroud that don't match any known artistic traditions from any historical period. These unique characteristics suggest either an unknown artistic technique or a formation process that operates outside traditional artistic methods. The pattern recognition analysis is also examining the mathematical relationships within the shroud's image, identifying geometric proportions and spatial relationships that might provide clues about intentional design versus natural formation processes. Environmental context analysis. AI systems are also analyzing environmental factors that might have influenced the shroud's formation and preservation over the centuries. The artificial intelligence can process vast amounts of data about climate conditions, atmospheric composition, and environmental changes that occurred in different geographical regions over the past 2,000 years. This environmental modeling is helping researchers understand how these factors might have affected the shroud's physical and chemical characteristics. The AI analysis is examining how different storage conditions, display methods, and conservation techniques might have influenced the shroud's current appearance. This information is crucial for interpreting scientific analyses and understanding how the artifact's characteristics might have changed over time. One particularly interesting aspect involves AI modeling of fire damage and environmental trauma that the shroud is known to have experienced. The artificial intelligence can map the extent of damage and identify areas where environmental factors might have altered the original characteristics. The environmental analysis is also examining pollen samples, dust particles, and other microscopic debris found on the shroud to build a comprehensive picture of the environments where the cloth has been stored throughout its history. Interdisciplinary data integration. One of the most powerful applications of AI to shroud research involves integrating data from multiple scientific disciplines to build comprehensive models that account for all observed phenomena. The artificial intelligence systems can simultaneously process data from chemistry, physics, biology, archaeology, history, and forensic science to create unified theories about the shroud's origins and characteristics. This interdisciplinary approach is revealing connections and patterns that wouldn't be apparent when examining each field separately. The AI integration is identifying areas where different scientific analyses support or contradict each other, helping researchers understand which conclusions are most reliable and which require further investigation. This systematic approach is bringing new objectivity to shroud research that has historically been influenced by personal beliefs and institutional biases. Perhaps most importantly, the interdisciplinary AI analysis is identifying specific questions that need to be answered to resolve the shroud mystery definitively. The artificial intelligence is essentially creating a roadmap for future research by identifying the most critical gaps in our current knowledge. The future of AI shroud research. Looking ahead, the future of AI analysis promises even more revolutionary discoveries about the Shroud of Turin. Next-generation AI systems will have unprecedented processing power and pattern recognition capabilities, potentially revealing details that current technology cannot detect. These future systems will be able to analyze the shroud at even finer levels of detail, possibly down to individual molecular interactions. Researchers are also developing new AI approaches specifically designed for historical artifact analysis, incorporating advances in machine learning, quantum computing, and advanced sensor technology. These specialized systems will be optimized for the unique challenges of analyzing ancient materials and controversial artifacts. The integration of AI with new scientific instruments and measurement techniques promises to gather data about the shroud that wasn't previously obtainable. This combination of advanced artificial intelligence with the latest scientific instrumentation could finally provide definitive answers about the shroud's authenticity and formation process. Most excitingly, future AI research might be able to simulate the actual image formation process, potentially recreating the physical and chemical conditions that created the shroud image. This could provide the ultimate test of different theories about the Shroud's origins. AI research into the Shroud of Turin has opened a new window into one of history's greatest mysteries, uncovering details never seen before, from microscopic fibers and blood chemistry to 3D reconstructions and image formation. Instead of settling the debate, these discoveries both support and challenge competing theories, leaving experts with more questions than answers. Whether it proves to be a genuine relic from the 1st century or an extraordinary medieval creation, one fact stands clear. The Shroud's complexity continues to astonish, and artificial intelligence is pushing us closer than ever to uncovering its secrets. Do you think these new AI findings prove the Shroud of Turin is truly ancient, or just a medieval masterpiece way ahead of its time?